Hi, this is Huda Zenham from Physics 2212, Section P. This is the second lab of the semester called Lines of Charges. To start, the purpose of this lab is to continue working on concepts of the first lab involved with the U-tape procedure and develop a more precise estimation of the charge Q and electric force in the U-tape. So instead of just using a single point charge for the tape, just as we did in the first lab, we're going to divide it into charge segments. And then we're going to see how the results compare. So for the charge, we can see in the second lab, I got a lower value for charge in magnitude compared to the first lab, and we'll see why later on. In the first lab, just as a recap, we made tapes charged and determined the sign of the charge, held one U-tape under the other to see repulsion, as we can see in the top right photo, and then we calculated the charge of the U-tape using Coulomb's law and developed a computational model of the two U-tapes. So on the bottom picture, we can see the two U-tapes are represented with the balls, and the gravitational force and the electric force are represented with the arrows. So some physics concepts that we have to consider, again, Coulomb's law and Newton's law, just as in the first lab, but now we are considering superposition, which is adding up all the fields of the divided sections to get the net electric field. Some assumptions that we have to make: we have to ignore air resistance, the U-tape holds the same amount of charge, the charge is uniformly distributed in the tape, and the segments are treated as point charges, so using point charge formula. So to set up our code, we have to set up some constants, such as the K constant, the gravitational constant, the mass of the tape, and then I indicated the original tape charge and the new tape charge that I got. The new tape charge I got it by using process of trial and error. So after running the code, every time I see what magnitude, like what value will give us the same value for electric force and gravitational force. Then we set up the electric field formula, which is E equals K times Q divided by magnitude of R squared times R hat. Then we defined the lines of charge and defined the top tape and bottom tape. And then we indicated we have to go through for loops that go through each piece of charge now. And this is for the top tape and bottom tape, and calculating E field and electric force. Finally, we indicate arrows for the forces and print the results. So here now we have a new model. We can see the divided up sections, and we have electric force, gravitational force, and all of this net electric force. And then we can see that the magnitudes are equal, just as stated before, so then we have a more accurate charge. So some things that we have to consider. Why are the charges different, and how much do they differ by? So I did the percent change formula to see that there's a 30% decrease from the lab 1 to lab 2 results. So why do they differ? Well, the methods of calculations are different. First, we only considered one point charge for each tape, but now we're considering many different divided up sections and then adding them up, which is essentially superposition, as stated before. So now we're going to say that the lines of charge is more precise because when you only do one calculation for one point charge, it might not represent the actual charge. Whereas if you do many different sections and many different calculations, there's a higher chance that you will get a result that more closely relates the actual result of the charge. Thank you and have a great day.